Howdy, this video will focus on factoring, just the basics, okay? So, the greatest common factor. This is the bee's knees when it comes to factoring, okay? So what is it? The greatest common factor is the largest factor of two or more integers, integers being numbers. Okay, so let's say we're going to find the GCF of 10 and 25. So 10 factors to 2 and 2, 5, and 1, okay? And 25 factors to 5 times 5 times 2, wait, no, oh, it's just 5 times 5 times 1, okay? So 5 times 5 is 25. So the greatest common factor, so the greatest number that's shared between both of these is 25. So the GCF is 5. Done. Now we can also do the GCF with variables. So x squared and x to the fifth. This one's really simple. The GCF is going to be the smallest of the x's. So x squared would be the GCF of x to the fifth. Simple, right? Now let's find the GCF of 3x, 12, and 6x squared. That didn't come out correctly. 6x squared. Okay. So the factors of 3x is just 3 and x. The factors of 12 is 3 times 2 times 2. 2 times 2 is 4. 4 times 3 is 12. And then the factors of 6x squared is 3 times 2 times x times x. So the greatest common factor that's shared between all of them is the 3, and that's it. Okay? So the GCF will be 3. Done. Alright, so moving on. Factoring binomials. So equations with just two thingies. Okay? So let's do the example of 3x minus 6. So the factors of 3x are 3 and x. The factors of 6 are 3 and 2. So the GCF between these two is 3. So we can factor that out. So what we're going to do is we're just going to take out the GCF. So we're taking our GCF and our GCF, and we're just going to take it out. So that would mean we're going to have 3 times x minus 2. And just to prove that this works, we're going to just multiply it out. So distribute the 3. So 3 times x is 3x. 3 times negative 2 is negative 6. And this matches that. Okay? Let's go ahead and do the second example. We have x squared plus 3x. Let's factor the x squared. So x squared is just x times x. And 3x is just 3 times x. So we're going to have x times x plus 3 times x. The greatest common factor here would be the x. Okay, so we're going to take that out. And that would give us x times x plus 3. Because we factored out the x. So just to double check, let's distribute the x. So x times x is x squared, and x times 3 is 3x. So x squared plus 3x equals x squared plus 3x. Now let's do our third example. Let's factor 6x squared. So 6 factors to 3 times 2. And x squared is just x and x. Then 8x cubed will just be 8 factors to 2 times 2 times 2. And then there's going to be 3x is x, x, x. So let's group this together. We have 2 x's here that are shared. So that's going to be included in our greatest common factor. And we have a 2. So we can factor out 2x squared from both of these. So if we do that, we're going to have, okay, so 3 times 2 times x plus 2 times 2 times 2 times x times x times x. And we're going to factor out we're gonna factor out a 2 and 2 x's. So take that out. So we're gonna have 2 times x multiplied to 3, because that's what's left, plus 2 times 2 2 times 2 times x, because that's what's left there. So x squared is, x times x is x squared, and then we have 2, so we're going to have 2x squared on the outside. Then on the inside, we're going to have 3 plus 2 times 2 is 4, and then the x, so we're going to have plus 4x. And then just to double check that this is correct, let's distribute. So 2x squared times 3, that's going to be 3 times 2 is 6, so that's going to equal 6x squared, plus 2x squared times 4x will be 2 times 4, that's 8. And then x squared times x is x cubed. So that's 6x squared plus 8x cubed. And that is correct. Okay. So the solution to our first example would be 3 times x minus 2. The solution to our second example would be x times x plus 3. And the solution to our third example would be 2x squared times 3 plus 4x. Okay, so moving on. Factoring groups from binomials. This one's pretty simple. This one's already set up for you. You just have to factor it out. So we have 3x times x plus 1 plus 5 times x plus 1. These are the same. So all we're going to do is just factor them out. So we're going to be left with x plus 1 times whatever's left. So 3x plus 5. And then our second example, we have x times 2x plus 1 minus 3 times 2x plus 1. 2x plus 1 is the same, so we can factor that out. So we're going to be left with x minus 3. So that's going to be 2x plus 1 and then x minus 3. And just to show, let's go ahead and follow this out. So we're going to distribute our 2x. So 2x times x and 2x minus 2x times negative 3, and then distribute the 1 times x, and then 1 times negative 3. So 2x times x is going to be 2x squared. 2x times negative 3 will be negative 6x. 1 times x is going to be just x, so plus x, and then 1 times negative 3 is just going to be negative 3. So then, combined like terms, we're going to have 2x squared minus, a negative 6 plus 1, a negative 6 plus 1 is going to be negative 5, so negative 5x minus 3. So this would be a standard form of that equation. Okay, so, continuing. Find the solutions to these factored equations. Okay, so remember that the solutions are the x-intercepts of the equation. So we already have our y equal to 0. So we just need to decide what x needs to be for this to equal 0 and what x needs to be for this to equal 0. So really simple. 5 plus what equals 0? So 5 plus negative 5 equals 0. So we're going to have a negative 5 equals x for that to equal 0. X minus 7. So negative 7 plus what equals 0? So 7 minus 7 equals 0, so we're going to have 7 equals x. So our solutions would be the roots. So our roots for this equation would be negative 5, 0, and 7, 0. For this example here, what are the roots of the solution? Now, this 4 doesn't really matter, okay? Because it's on the outside. But if this equals 0, then 0 times 4 is just 0. 0 times this would be 0. So what makes x minus 1 equal to 0? So then 1 minus 1 equals 0. So we're going to have x equal to 1 to make this equal to 0. And we're going to have x equal to 2 to have this equal to 0. And both of those would be a solution to this example. So that means our roots would be 1, 0, and 2, 0. Now for our third example, let's go ahead and decide what makes this 0 and what makes this 0 to find our roots. So 2x minus 4. Simple way to do that, we're going to have 2x minus 4 equal to 0. Let's solve for x. So add 4 to both sides. So 2x equals 4, divide by 2. So x equals 2 to make this equal to 0. Let's go ahead and solve for our second one. So 3x plus 9. Let's decide what x needs to be to equal for the equation equals 0. So set it equal to 0. So minus 9 both sides. It's going to be 3x equals negative 9. Then divide by 3 to get x by itself. And we're going to have x equals negative 3. So our roots would be 2, 0, and negative 3, 0. Oh, and how about that, guys? Let's end this presentation, this PowerPoint. So I hope y'all understood the PowerPoint, and thanks for watching the video. And that's all, folks. See y'all in class.